So today's topic is excess and limiting reactants. Now to first understand, we can propose a situation in which there are 12 pens and 5 caps. And your goal is to sell these pens. But to sell a pen, you'd have to have a cap with it because you don't want to sell a pen without a cap. So given these numbers, the question is, how many pens can you sell? I think that's pretty obvious to say that it's 5 pens, each with a cap of its own. Now at the end of this process of you selling these pens, we can say that there are 7 pens left and 0 caps left. Now looking at this, we can say that the pens are in excess, or in this process, they're the excess reactants. And this is because they remain after the reaction stops. While on the other hand, we can say that the caps are the limiting reactants. And this is because it limits the products formed. Because if you look at the process above, we can see that initially there were 5 caps, but you can only sell 5 pens because the caps limit the amount that you can sell. I think also from here on, we can also say that the reaction stops when it is used up. Now, relating these concepts to a more familiar situation in chemistry, such as a complete combustion of an organic compound, such as methane, plus O2 gives CO2 and H2O. Now balancing these out, there's a 2 here and a 2. Now looking at this equation initially, we don't know which one is the limiting and excess reactant, but from our previous knowledge, we know that complete combustion only happens in a rich oxygen environment. Now, what does this mean? This essentially means that oxygen is in excess and your organic compound that you're burning is the limiting reactant. But how about a situation in which you don't have any knowledge of which one is the limiting and excess, such as nitrogen and hydrogen giving ammonia. So in this situation, you can't tell right away which one's the limiting and excess. So in cases like these, they'd give you values for your reactants. So for example, they'd give you 18 grams of nitrogen and 2 grams of hydrogen. And your objective is to find the limiting reactant. Now to do this, you'd have to undergo some calculations. So the first step is to find the number of moles. Of your reactants. So we could say that the moles for nitrogen are equal to mass over molar mass, which are equal to 18 grams, which was your given mass, over 28.02. And that gives 0.64. On the other hand, you have the moles of hydrogen, which give 2 grams, which was your given mass again, over 2.02. That gives 0.99, of course, moles and moles. Now your second step is to compare their ratios, or to derive their ratios. Now that can be found by using this formula, which is the number of moles of the reactants over the balancing number. So for nitrogen, we can say that it is 0.64 over its balancing number, which is 1, which still gives 0.64. And the ratio for hydrogen is 0.99 over 3, which gives 0.33. Now from here on out, it's pretty easy to determine which one's the excess and limiting. And the rule is the excess reactant has the greater ratio. And the limiting reactant has the smaller ratio. So looking at these values, we can say that 0.33 is less than 0.64. So the ratio of hydrogen is less than the ratio of nitrogen. So therefore, hydrogen is limiting. And from here on out, you can do a lot of calculations with this information that you've found. So such as the theoretical yield or how much mass is remaining. So following on from this example, they say your objective is to find the mass of excess reactant left in grams, because we know that the excess reactant at the end of the reaction, it's the reactant that always remains. So to do this, we'd have to find the theoretical yield for nitrogen, because if hydrogen is the limiting reactant, it will only react with a certain amount of nitrogen that we have. So to do this, we compare their ratios. Hydrogen, which is essentially comparing their balancing numbers, 1 to 3, and their moles, which is 0.99. Therefore, moles of nitrogen are equal to 0.99 over 3, which gives 0.33. And then we know that mass is equal to moles times the molar mass, which in this case is 0.33 times 28.02. And that gives 9.2466, which is approximately equal to 9.25 moles, to an appropriate number of significant figures. So what you found here is your theoretical yield, or essentially the amount of nitrogen that has actually been reacted. So to find remaining N2, you can say that it's the total amount minus your theoretical yield. And that gives 8.75 grams. And that's essentially it.